greeting for to all of you. Myself is Nikhil Kumar. Now today I have the lecture on discrete structure and theory of logic. That is the code BCS 303. Actually, discrete is something that is non-continuous. There are two terms. First one is discrete and second one is continuous. Continuous is something that is regular in mode. Eh, and discrete is something that is we can say that it can be integer, pupil and houses. What is integer? Integer is the value that have 1 2 3 surroundings. Okay, so we will discuss here is discrete objects and discrete structure, the abstract mathematical structure used to represent discrete objects and relationships between the object, that is sets, relations and graphs. Why do we study discrete structures? Actually, in the form of computer, we only use two terms, that is 0 and 1. That are the logical bits. Okay, we do everything in the form of bits 0 and 1. You need to know the basic language and conceptual foundation for all the computer science, that is discrete structures. Discrete structure concepts are also widely used through math, science, engineering, and most of the languages and subjects related to this. Widely source of data structure and the applications that are connected to the discrete structures are networking. Most of the times, there are many of the fields where we use of discrete structure in computer science. Most of the time, we will find that these are the core areas where we can find discrete structure. In the networking case, in database, image processing, programming language, compiler software, artificial intelligence, operating system, these are the main core area where we will find the discrete structures. The main part in the discrete structure is the propositional logic. What is the proposition? A proposition is a declarative statement, a statement that is declare a fact. All the points and the declaration statement are considered in the propositional logic. It may be true and it may be false, but not both. That is the main point. It cannot be both. It should be true or false. The area of logic that deals with propositions is called propositions logic. Just for example, I take Akgec is one of the best engineering college in NCR. As we know that Akgec is the one of the best engineering college. So it is the statement and we can say it is the propositions. Other statements are every cow has 4 legs. 3 plus 2 is equal to 32. It's what is this? It is the false statement. 4 plus 3 equal to 7. That is true. Propositional logic applications. We are using propositional logic as a foundation for formal proofs. All the logical connectivities we will discuss are also found in hardware and are called gates. We can prove all the proposition logics through the gates that called the logical gates. That may be logical and logical or, logical not, logical XOR and many more. We use letter to denote propositional variables using variables. Truth value of true proposition is denoted by T and the false statement is considered as, is write down with the word alphabet F. What is the negation? Negation, suppose P is a proposition, the negation of the P is written as negation of P. That is the symbol for negation and has meaning. It is not the case that P. What does it means? That it is not the case that P have. Okay. The proposition negation of P, it is called as negation. Negation of P is read not P. Okay. So this is the truth table. It is P, that is, what is this? Proposition P, and it is the negation of P. Okay. That have contained two value, false and true. If P indicate false value, that negation of P will be true. Okay, and if it is true, then negation of P represent what? False. Propositional logic conjunction. The second point is conjunction corresponds to English and. It is the logical and in the logical concept case. What is conjunction? Let P and Q be two propositions. Okay, we assume that P and Q are the two propositions. The conjunction of P and Q denote by P conjunction Q. It should be called and, logical and. Okay, is the proposition P and Q. The P and Q is true when both P and Q are true, otherwise false. Okay. For example, today is Friday, it is raining today, and it's represent P and it's represent Q. So P and Q, today is Friday and it is raining today. For this, we can create the truth table for the conjunction, that P, Q, P, logical Q. Okay. How it can be represent if both the case are true. In that case, the value of P, logical and Q will be true. Otherwise, in all the case, it will be false. So Friday, false and false, it will be false. It will be also false. It will be false, and true will be as true. The other term is disjunction, correspond to English or, that is a logical or. What is disjunction? Let P and Q be the two propositions. The disjunction of P and Q denoted by P, logical or Q is the proposition P or Q. The P or Q is false when both P and Q are false, otherwise it will be true. That means if one of the entity will be true, then the logical function will be true. In the same example, we can create the truth table for this logical P, and for the P and Q, for the propositions, we create the truth table for this. False, false, it will be false. False, true, 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 false, true, and true, true, true. That means if the case false, both the predicates are false, that is the only case when we find the result false. Otherwise, it will be true for all the cases. The propositional logic, that is exclusive or. Exclusive or. Let P and Q be the two propositions. The exclusive or of P and Q denoted by, it is denoted by, that is a symbol of exclusive or. Is the proposition that is true when exactly one of P and Q is true, otherwise false. The truth table for exclusive or is this, that if one of the element is differ, that means in both the predicates, if the value are differ, then we find the truth value, otherwise it will be the false. That means if both the elements are false, then the value will be false. If both the values are true, then we find the false. Okay. Otherwise, if both the values are differ, then we find the truth value, that is truth. Propositional logic, conditional statement. The next point is conditional statement. As we discussed and we know very well in the language C, as we know already discussed, most of the students will be know about language C. There is the concept of the conditional statements. Mostly it is indicated by language alphabet keyword if. Okay, it corresponds to English if P then Q. That means if the predicate denote the value P, then what will be the result? If these conditions, that means if P predicate's value will be true, then Q will be true, otherwise it will not be true. Conditional, let P and Q be the two propositions, the conditional statement implications, and it is denoted by P tends to Q, where P and Q are two predicates. The value of P, if the value of P is true, that is the conditions, then Q will be true, otherwise false. Let's take the example. If it is raining, then it is cloudy. Or the second example is, if I am elected, then I will lower taxes. Actually, what's happened? We change the statement or the fact, we change the statement into predicate forms. That means P or Q and something else variables, and with the help of these predicates, we conclude them to a possible cases basis on the propositional logic, as we discussed. So the truth table for implications is this. There are two predicates P and Q, and having the some values, maybe there are two variables P and Q. So the total case can be occur 4, 2 to the power 2 equal to 4. Value can be false false, false true, true false, and true true. Okay, but in case of P implication Q, we can only a specific value. That means if true predicate P is true, then only, and Q is false, then for the P implication Q case, we find the conclusion false, otherwise in all the cases we find the value true. If predicate P tends to Q, if predicate P tends to Q have there are two predicates P and Q, and the implication is P tends to Q, then the result will be true, will be false in only the case when P is true and Q is the false, otherwise we find the true cases. Okay. Propositional logic special definitions. Q tends to P is converse of P tends to Q. Okay, P tends to Q, if it is known, then I am hungry. There are some points we discussed, and with the use of the example and definition with the predicate formulas in the previous slides of the conditional statement P tends to Q. These are some examples. Inverse, for the inverse case, P tends to negation of Q is inverse of P tends to Q. That means the conclusion of this slide is that if P tends to Q has same truth value, that is negation of Q tends to negation of P. Okay, if we generate a truth table from regarding this, suppose there are only two variables, or we can say that is the two predicates, predicates A and predicates B, and there is the case A tends to B. So the truth table for this is A, B, A tends to B. For this, the possible cases for this: false false, false true, true false, and true true. Okay. For the predicate A tends to B, the only possible case where we find the truth value, that is if A tends to B is formed where there is the value true and false, then we find the false value, otherwise we find the truth value. It is the rule of the prediction. Implication rule. We can change any statement or any propositional statements in the form of predicates rules. Propositional logic. Now it is a time for to explain the biconditional statement. It corresponds to English P if and only if Q, and it is represented by biconditional statement, by implications. Okay, and it is and it can be read as P if and only if Q. The biconditional statement P biconditional Q is true when P and Q have the same truth value, otherwise false. The truth table for this is that there are two predicates P and Q, and it is represent here P biconditional Q, and the truth table is that there are possible cases if the value of P and Q are same, then we find the truth value, otherwise we find the false value. This is the biconditional statement. And how can we change? So let's suppose the predicate P have the statement you can take the flight, and the other one predicate is Q, that so you buy a ticket. So what does means P biconditional Q, you can take the flight if and only if you buy a ticket. It is the biconditional statement. Propositional logic precedence. Okay, the precedence for the logical operators is that logical note represents that it is logical and logical or, implication and biconditional. It is logical and. So the precedence is this one. So when there are the lot of operators are used, logical operators are used, so we maintain and follow these structure and maintain use on the basis of priority on the precedence. Like firstly we will solve out the negation, then logical and, then logical or, implication and, last one biconditional statement. A compound propositional that is always true is called a tautology. Okay, if the conclusion of the statements and the propositional logic so the truth value, then all the values are true, then it is called tautology. If in the conclusion case all value always false, where the conclusion show the all values false, that is called the contradiction. Neither a tautology nor a contradiction is called contingency. Okay, if there is only one variable p, if only one variable, the number of total case will be 2 to the power 1 equal to 2. The total case be 2. If the variable is p, that is the predicate, the values will be such that false and true. The negation of p, how it represent? If the value is false, then the negation of p will denote true, and if value is true, then it shows false. P logical or and negation p. That means, as we previous slides we discussed about the logical or case. If one of the variables contain the value true, then the result will be true. False, true, 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 false, true. It shows the tautology. And the case p logical and negation of p, for this, if both the values contain the truth value, then the result will be true, otherwise false. Here false, true, false, true, false, false. It's the conclusion for this predicate rule. So all the values are false, that is contradiction. And what is satisfiable or contingency? When neither we have the tautology nor the contradiction, then it is called satisfiable or contingency. Propositional logic, compound propositions. So this is a question, very important question. For this we generate the truth value or truth table. Here there are two predicates p and q. If there are two variables p and q, so number of possible case will be 2 to the power 4. 2 to the power 4 is 4. So possible case will be 4. For the case p and q, false, false, true, false, false, true, and true, true. For negation of q, for the value false, it is true. For false, true, and for true, false, true, and false. That means the value in q represent the negation of q will be the just revert or the just inverse. Okay. For the p logical or negation q, that means for these predicates the value will be true if one of the predicates value is true. False, true, 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 true. Here both the values are true, so the result is true. Here both the values are false, the result is false. And here one value is true, it is true. So according to these rules and the previous slides, the conclusion shows this one, and it is the contingency. Not true, all values are true, not false, it is contingency. Thank you.